China just built something that sounds impossible. A wearable robot that turns a regular person into something that moves like a centaur. The machine does not attach to your legs like normal exoskeletons. Instead, it gives you two completely separate robotic legs that walk behind you and carry the weight while you move naturally. The result is a hybrid walking system where human and machine share the work. And the numbers from testing are shocking. People wearing this system reduce their energy use by 35% while carrying heavy loads. Foot pressure dropped by 52%. The robot legs supported more than half the weight while the person walked in a fairly normal pattern. This is not a prototype sitting in a lab. This is published research showing that humans can now walk further, carry more, and use less energy than biology allows. Researchers at the Southern University of Science and Technology in Shenzhen built this wearable robotic platform with a surprisingly simple idea. Traditional exoskeletons attach robotic joints directly to human legs, trying to amplify the power of muscles that already exist. This system takes a completely different approach. It adds two fully mechanical legs behind the user. When the person walks, the robot legs walk along with them and help carry heavy loads. The system connects to the user through an elastic interface mounted on the back. That means the robot is physically linked to the person, yet it operates as a separate pair of limbs rather than an extension of human legs. The human still controls balance and navigation, while the robotic legs handle a large portion of the weight and forward movement. The result creates a hybrid walking system where human and machine share responsibilities. The robotic legs move in sync with the wearer's walking speed and direction. Motion planning algorithms and control systems coordinate the steps so the robot remains aligned with the human stride. The researchers used model predictive control along with trajectory planning techniques to keep the movement stable even under changing walking conditions. One of the most interesting parts of the design is the elastic coupling between the human and the robot. The connection includes non-linear stiffness, meaning the behavior changes depending on the load. When the load is relatively light, the coupling stays firm, so the human and robot move together in a very coordinated way. When the load increases, the connection becomes more flexible. That flexibility allows the robotic legs to absorb forces and take over more of the load-bearing work. The numbers from the experiments are actually pretty significant. In tests, participants carried a load of about 44 pounds, which is roughly 20 kilograms. With the robotic legs assisting, metabolic energy consumption dropped by about 35% compared to walking with the same load normally. At the same time, foot pressure was reduced by about 52%. That means the system does not just make walking easier, it dramatically reduces the physical strain placed on the human body while carrying heavy equipment. During the trials, the robot legs were able to support more than half of the carried weight, while the person continued walking in a fairly natural pattern. Researchers also measured stability during movement. When people walked with heavy loads using the robotic platform, the variability in step width decreased. In other words, their walking pattern remained more stable even while carrying weight. The team believes this type of wearable robot could become useful for a range of demanding tasks. Military logistics is an obvious example where soldiers often carry extremely heavy gear over long distances. Disaster rescue operations are another scenario where responders need to move equipment across uneven terrain. Industrial environments could also benefit, especially jobs where workers transport heavy supplies repeatedly during the day. The platform redistributes vertical loads while also providing horizontal traction assistance. That means it supports the weight and helps push the user forward at the same time. The result is that people can travel longer distances with less fatigue while carrying large loads. The research describing the Centaur-style wearable robot was published in the International Journal of Robotics Research. Another development comes from researchers at the Beijing Institute for General Artificial Intelligence who introduced a new motion framework called Omni Extreme. In their demo, a Unitary G1 humanoid robot performed a long sequence of highly athletic movements that most robots still struggle with. The robot executed breakdancing routines, martial arts kicks, forward rolls, butterfly kicks, cartwheels, alternating pistol squats, and push-ups. It even performed 5 consecutive Webster flips and finished with a rapid series of back handsprings. Some of the routines included Thomas flares and b-boy style spins that require fast contact switching with the ground. Highly dynamic movement has always been difficult for humanoid robots. Reinforcement learning is usually used to train these skills, yet once the number of movements increases, control becomes unstable. According to researcher Sang Huang, many previous demonstrations relied on overfitted tracking policies trained for one specific motion, which makes switching between different movements unreliable. Omni Extreme approaches this differently using a two-stage learning system. In the first stage, a unified base policy is trained using dagger-based flow matching to aggregate motion prior from multiple motion tracking experts. In the second stage, that base policy is frozen and a residual policy is optimized under strict motor constraints, domain randomization, and power safety regularization to close the gap between simulation and the real world. The result is a single algorithm capable of controlling many extreme motions instead of training separate policies for each skill. According to Big Eye, the framework achieves success rates above 90% across multiple high dynamic tasks. Researchers also conducted ablation studies to test which parts of the system matter most, measuring robot stability, movement success rate, joint energy load, and safety. The overall goal is to balance realistic motion with scalability, allowing humanoids to learn many complex skills without retraining the entire system from scratch. Meanwhile, in healthcare, researchers working on a system called Meadows have introduced a new set of intelligent dexterous gloves designed to help doctors perform delicate medical tasks with AI assistance. The gloves are part of a larger project led by a joint Stanford and Princeton research team, and the idea is to bring artificial intelligence directly into real medical procedures. Instead of AI sitting on a screen analyzing scans after the fact, Meadows is designed to work alongside clinicians while procedures are actually happening. These new intelligent gloves allow the system to assist with extremely precise hand movements, including suturing, knot tying, and handling surgical instruments. The goal is not to replace doctors. The goal is to give them an AI-powered layer of support that can help improve precision and reduce the chance of human error during complex procedures. If you found this video helpful, make sure to like, subscribe, and hit the notification bell so you never miss our latest AI and robotics updates. For more cutting-edge tech content, check out AI Tech Academy, where we break down the technology shaping tomorrow. Thanks for watching, and I will see you in the next one. While the world was looking elsewhere, China deployed its first robot police force. Humanoid machines now patrol alongside human officers in multiple cities. Spherical robots chase people through crowds. Combat models demonstrate martial arts on camera. This crossed from concept to reality faster than anyone predicted, and the footage coming out is hard to believe. The first major deployment involves a humanoid traffic police robot called Wu R001, which has officially begun service as the world's first humanoid traffic officer. This next-generation realistic humanoid was designed specifically to operate in dense urban traffic conditions and integrate directly into smart city infrastructure. Wu R001 functions as a full-fledged intelligent assistant for traffic police departments. The robot's human-like design allows it to perform standard traffic control gestures, including clear stop signals, direction guidance, and warnings about traffic flow changes. Thanks to carefully engineered joint mechanics and precise motion synchronization, the robot operates smoothly and confidently without abrupt or chaotic movements. This becomes especially important at busy intersections where jerky or unpredictable motion could confuse drivers or pedestrians. The system runs on a collection of sensors including high-definition cameras, LiDAR scanning modules, and multimodal environmental perception systems. The robot analyzes traffic conditions in real time, recognizing vehicles, pedestrians, and cyclists while tracking their trajectories across the intersection. This allows Wu R001 to understand complex traffic patterns and respond appropriately to changing conditions. But traffic control represents just one application. Recently in China, a combat humanoid police robot called T-800 also entered service, attracting massive public attention and becoming a viral internet topic due to its unusual appearance on the streets alongside real police officers. This humanoid robot stands approximately 1.73 meters tall and weighs around 75 kilograms, including its battery. T-800 is equipped with an advanced artificial intelligence system and comprehensive sensor equipment, including 360-degree cameras and LiDAR scanners that help it navigate its surroundings and move through streets. Thanks to this technology, the robot can confidently walk on sidewalks, change direction smoothly, and maintain balance, which becomes crucial for operating in real crowded environments. Developers paid special attention to movement dynamics. In demonstration videos, T-800 shows high joint mobility, rapid torso rotations, and stability during sharp maneuvers. The robot is capable of performing complex coordinated movements, including elements resembling martial arts techniques such as kicks, blocks, and training combinations. This capability demonstrates the platform's potential for situations requiring physical intervention. In China's Xinjiang province, a traffic control robot named Xinjiang No. 1 has entered service. The robot was developed with participation from the local traffic police department and technology specialists as part of a program to introduce intelligent systems into smart city infrastructure. Xinjiang No. 1 is a humanoid platform capable of performing classic traffic controller gestures, giving stop signals, allowing movement, and directing traffic flows at busy intersections. Its movements are based on pre-recorded algorithms modeled on the actions of real police officers, making the signals clear and recognizable to drivers and pedestrians. The robot is equipped with high-definition cameras, a computer vision system, and environmental analysis sensors. It can monitor vehicle and pedestrian movement in real time, detect potential traffic violations, and, when necessary, issue warnings through a built-in audio system. Moving from humanoid robots to a completely different form of robotics, a spherical police robot has also appeared and begun operating in China. This unusual robot externally resembles a large ball or sphere inside which mobility mechanisms, sensors, and computing electronics are housed. The core of the spherical police robot consists of integrated cameras and sensors that provide full situational awareness. With these systems, the device can detect people, vehicles, and abnormal situations in crowded places such as shopping streets, parks, or metro stations. Data processing occurs in real time using built-in artificial intelligence that analyzes object behavior and assesses potential threats or disturbances. In several presentations, footage showed that the robot can quickly pursue a fleeing person due to its high mobility speed and can deploy built-in intervention tools such as irritant spray systems or mechanisms designed to temporarily restrict a suspect's movement. Unitary G1 has begun operating on city streets as part of patrol units. The primary goal of G1 is not to replace human officers, but to serve as a reliable assistant capable of handling tasks that are difficult or dangerous for people. The robot was developed by Unitary Robotics and adapted for urban environments where mobility, stability, and constant situational monitoring are required. Unitary G1 is a compact mobile platform with an advanced stabilization system and high maneuverability. Thanks to its well-engineered design and balancing algorithms, it can confidently move along sidewalks, avoid obstacles, operate in dense pedestrian traffic, and maintain stability on uneven surfaces. This makes it a practical tool for patrolling busy districts, tourist areas, and public spaces. The robot is equipped with high-definition cameras, a computer vision system, and environmental analysis sensors. Police in Sichuan province have also decided to deploy several types of robotic assistants, including traffic control robots and robotic dogs, intended to support patrol and special units. Footage shows a traffic control robot helping manage vehicle flows during peak hours. It is equipped with computer vision, high-resolution cameras, and multimodal artificial intelligence, allowing it to track vehicles and pedestrians in real time. In addition, demonstrations feature a robotic dog, a mobile quadruped platform used for tactical support. Such machines can move quickly through urban environments, maintain stability on uneven terrain, and conduct video surveillance. One of the functions demonstrated for these robots includes the ability to deploy a remotely operated net device intended to temporarily immobilize suspects during training scenarios. Within Chinese police forces, robotic dogs play a role comparable to traditional canine units. One example is the Robo Canine project presented in the city of Hefei. This robotic platform has been integrated into law enforcement services as a mobile assistant for patrol monitoring and support during special operations. Robo K9 is built on a quadruped robotic platform with high stability and an adaptive balancing system. Thanks to a design with independent drives on each leg, it can move across uneven surfaces, steps, curbs, and tiled areas while maintaining stability even during sharp maneuvers. This makes it especially effective in complex urban environments. The robot is equipped with high-resolution cameras, a 360-degree vision system, and environmental sensing equipment. It can transmit live video feeds to a command center in real time, providing officers with additional situational awareness. Engine AI has also deployed its humanoid police robot, which has begun appearing on the streets of Chinese cities alongside law enforcement officers. This model, finished in a distinctive black and grey color scheme and equipped with a bright green vest, has become part of pilot programs aimed at integrating humanoid robotics into urban security systems. If you found this video helpful, make sure to like, subscribe, and hit the notification bell so you never miss our latest artificial intelligence and robotics updates. For more cutting-edge tech content, check out AI Tech Academy, where we break down the technology shaping tomorrow. Thanks for watching, and I will see you in the next one.